Welcome back, thrill seekers. Sorry about the noise, sorry about the mess. Just showing you what I'm up to. It's been running for about half an hour now. It's running on a 3 amp hour battery, car battery, 12 volt. That's the amps going in. We've got 500 milliamp going in. That's the battery voltage. It's been stable on that for quite some time. I've got a couple of questions about this. We're doing about, just over 20,000 RPM on a 6 watt little setup. The rodent coil there is my drive coil. This Mott coil here is my trigger coil. I've got to tune that trigger coil. So the closer I get, there's a spot where if you get too close, it just stops. It drops down to 20 milliamp current draw, and then then the motor just won't run. If you bring it too far back, like if you bring it back here, it'll go up and it'll be drawing about 1.2, 1.3 amps. But the speed doesn't get any faster. So if you get it just right, you get that low current draw of 500 milliamps, and you get maximum speed. This coil here is my generator coil, bipolar wound, laminate core, and it is unloaded. It's generating about 230, 240 volts. There's a little bit of lens drag on this, but not a lot at that distance from the magnet. If I get it any closer, I'm going to get a lot more drag on the motor. I don't know what the current output of that coil is. I think the last time when I had this rig set up and I measured it, it was about anywhere between 50 to 80 milliamps, something like that. But I just thought I'd show you what we're up to. You can hear the bit of noise. I think my bearings are on their way out. They've done a lot of hours. Anyway, I don't know why the movement of this changes the current draw. Can't work out that. That's just connected to the base of my transistor. It's using a little MOSFET circuit. That's really about it. So there's not a lot of room to get another coil in here to sort of double the output. You can see that still sort of hovering around that. I'll just check that RPM. Anyway, thought some of you might find that useful. Battery. So this is just hooked up to a full bridge rectifier going into a large cap, which is then just in parallel to the battery. I don't know if there's a better way of getting that charge from here back into the battery. But basically, just got a bridge rectifier, this ugly mess over here, which is just from the bridge rectifier into the cap and then straight back into the diodes. I haven't got any straight back in the diode, straight back into the battery. I don't have any diodes or anything on the battery itself. So as we go out of the bridge rectifier, straight into the cap, and then in parallel straight into the battery. It'll charge a 9 volt battery up pretty quickly. If, for instance, I'll just disconnect. I'm just going to disconnect the battery and show you how fast the cap charges up. So we're disconnected from the battery at the moment. We're just charging that cap. So that's a 16 volt, 20,000 UF cap. And I better connect that battery so I don't blow it up. But even when I'm charging that, there's no real discernible change. So that's disconnected at the moment. There's no discernible change to the current draw there. Anyway, I think it's pretty efficient, but trying to work out what the next step is. Thanks guys, bye.